Okay, Assalamualaikum warahmatullahi wabarakatuh. This is my next video lectures for our chapter 5, okay, on example 2, page 67. So if you look at example 2, this is a list. We'll be using least squares procedure by using other model, which is number 4 on page 64. Okay, so we'll be using y equivalent to ax power of k. On the table it was written y equivalent to ax power of b, so it's that k is the b. Okay, so for this one is a discrete data, so you're given this n, there are 6n here, 6 pairs of data. So since we choose number 4, model number 4, y equal to ax power of k, so next step is to naturalize that log by ln on the left hand side and also on the right hand side. So next is to identify this ln y on the left hand side as your capital Y. Okay, next is to identify your ln a. Okay, ln a, this one is ln a. So this one, from here we put ln a x k. So this will become this one. Okay, so this multiplication becomes this plus. So identify your ln a as a naught, then your k as your a1, then ln x as capital of x. So you have this new capital of y, capital of x function, and also coefficient a naught and a1. So next is to create the table. Actually you can directly use your calculator, but then for this one usually during final you need to calculate it. So first, because you need to identify this x and y, this capital X and y, so recall the previous steps where your capital Y is equal to ln y, your capital X is your ln x, your a naught is your ln a, and your a1 is that k, or in the model we use b. Okay, then rewrite it in the table. The first column is your x value, second column is your y value. Okay, then you identify your capital of x and your capital of y, either one, ya, benar kat sebelah pun boleh, or you identify your capital of x as ln x. So use the calculator, type ln, then your x, ln 1, then ln 1.15, ln 1.4, and so on, so on, so on. Next is we need to identify our x squared, y x squared, because if you refer to your matrix, in this set of matrix, we know that we need this x squared. Okay, so you, from this third column, squared every single values. Then for y is equal to ln y, so refer to column y, put ln y 4.33, ln 4.58, ln, and so on, so on, so on. Then multiply this x and y, then you got the last column here. Okay, last column here. So next is to sum it up, your x squared, your capital Y, your xy. Okay, then we put it in the matrix form, the normal equation. Okay, so you have your n, remember that one. So you have your n, your summation of x bar, yeah, maksudnya capital of x bar, x, capital X, then your capital X, then capital X squared. Okay, then your a naught, a1 equivalent to your x, your summation of y, yi, everything is in terms of I, then your x capital of x capital of y. Okay, so just substitute into that one, then you can use your calculator. Okay, so next is once you got this one, the value of this value, you can use your calculator again, or you can use you can calculate manually using Kramer's or Gauss. So you should end up with your a naught equivalent to 1.4649, your a1 equivalent to 0.4239. Okay, so refer back to your refer back to this one, where your x, your capital Y is ln y, your capital X is ln x, your a naught is ln a, and your k is equal to a1. So from this value we need to convert it back, because we are basically, our target is to identify y equivalent to ax power of k. This is the last equation that we want to have. So we need to identify what is a, what is k. Okay, So we know that k a1 is k, so basically this one is directly substitute into the equation. Okay, so a naught ln a is a naught, this one. Okay, remember ln a is a naught, so we need to identify that a. So we know that a naught is this one, so we use exponential ln, and exponential a naught. So this one. So this is your a naught. Just use your calculator, calculate this one, and you should end up with this 4.327. Okay, so you got your a, you got your a, you got your k, and that's it. This is just small x, your y, the original function normal. Okay, normal can. So you got your y equal to a naught plus a1 x. So this one, sorry. Okay, this one is, sorry, yeah. And last yang abaikan yang ni. So we focus on the last part, this one. Okay, that's it. Up till that one only. So you got your model number 4, y equal to a x power of k. That's it. Okay, next is try to do this warm-up exercises using the question asks you to use y equal to ae x power of x plus be power of minus x. Okay, so that's it. Next video we'll go to 5.3. So this one is based on continuous data. Yeah, this one is discrete. Before this, example 1 and 2 is discrete data. So 5.3 is continuous data. So I'll go directly to example 4, this one, yeah, in my next video on page 72. Okay, that's it. Assalamualaikum.